Hello and welcome. I'm going to take a look at how RAM affects performance. The effects I'm going to describe are already known, but I'm not aware of them being tested in the way I have done. I will quickly cover some observations as a setup to why I'm doing this testing and what I hope to see from it. I bought my current gaming laptop about 2 years ago. At the time it was an above average one with an 8-core Ryzen CPU and an NVIDIA 3070 laptop version. It came with two DDR4 3200 8GB modules, and I didn't think much about it until it came to an upgrade. Being a laptop, I knew I couldn't increase the RAM speed, but that didn't mean I couldn't get more performance out of it. I knew they would be single rank modules, and I could replace them with dual rank ones. At the time I could increase the quantity a bit, and I should get a boost that way as well. The results before and after blew me away. I just wasn't expecting that much difference. For these results I normalised it so that higher is better, with the reference case being the original RAM. In 1080p gaming, of the 4 titles tested I got improvements as little as 4% to as high as 34%. In compute, Y-Cruncher saw 35 to 41% increases. Prime 95 really liked it and more than double performance. This just smashed my expectations. Aida 64 bandwidths see between 9 and 38% improvement, with no difference to latency. This phenomenon was first reported around the middle of 2021. Laptop RAM was moving to a configuration known as 1 rank by 16, which is what my laptop came with. This performed worse than the more common type RAM before it, known as 1 rank by 8. On screen now you can see an Asus article where they go into more depth as to why the industry moved to lower performing RAM type and try to downplay its effects. I won't repeat it here, link is in the description if you want to read it up. I went a step further, going to 2 rank by 8 configuration. This wasn't easy to shop for. At 16GB, modules in the industry have been moving towards 1 rank by 8 for a while. I didn't want or need 32GB, which would likely be 2 rank by 8. In the end I found Kingston offered a choice. Not sponsored, but you can check them out if you want a specific RAM type. In the past I often went to Crucial, but they didn't allow you this level of choice. As interesting as this laptop RAM upgrade was, I felt like I was missing wider understanding in the potential RAM configurations. There was a middle ground between the two types of RAM tested. We had 1 rank by 16 that came with the laptop, and 2 rank by 8 that I replaced it with. But there's still 1 rank by 8 in between. How does that fit in? If we move to desktop, we also have up to 2 DIMMs per channel, which may also affect performance. I thought this testing would be more interesting than doing it on the laptop. So I hit eBay and managed to find some 1 rank by 16 modules cheap-ish. I could have got some new from Kingston, but it would cost a lot more. If I'm going to buy low performance RAM for testing, I don't want to spend any more on it than I have to. So to recap, that's 6 test configurations I'll be using. 1 rank by 16, 1 rank by 8, and 2 rank by 8. Each of those tested twice, once at 1 DIMM per channel and again at 2 DPC. Everything will be in dual channel. It's just not worth going to 1 channel. A quick look at the modules I'll be using for testing. These are Corsair Vengeance Pro RGB sticks. They are 2 rank by 8 configuration, and this is what I normally use in my test desktop. These modules are G.Skill Ripjaws IV, and they're pretty old. I think I got them in 2015 when DDR4 was still relatively new. These are 1 rank by 8 configuration. And last and definitely least are these bad boys. These modules are made by Samsung, and they have HP part number stickers on them, so they're probably pulled out of some cheap and nasty HP desktop. I had to hunt these down on eBay, and it kind of hurts to buy, well, intentionally buy low end RAM like this, but I did it because I just wanted to know how does it perform. On the testing, I specifically focused on the configurations discussed, not speed, not latency, not capacity. To ensure a level playing field, all modules will run with XMP disabled and at a speed of 2133 at JEDEC standard timings. I know this is not exactly high performance and most people would be running higher speed memory in their systems, but this is the only way I could remove variables easily and make sure the configurations are what I'm testing and not another factor. The tests I chose fall into 4 categories: gaming, compute, rendering and synthetics. This is slightly different from the laptop testing earlier. As before, I normalised it so that higher is better in the charts, with the reference case in this case being the 2 1 rank by 8 modules in dual channel. This is probably the most common configuration in a value conscious enthusiast build. I chose 4 games to test at 1080p resolution. The GPU used was a 1080 Ti, so it is getting a little bit old. The CPU is a Intel Rocket Lake 11700K. First up is Final Fantasy XIV Endwalker benchmark at maximum settings. So this game is one I've been playing for a long time, and the game itself is based on pretty old code. The game origins are from about 2010. They have been updated since then, but it still has roots in that era. The benchmark gives both average FPS and load time. In this game, we can see that the 4 1 rank by 8 modules give the highest performance, with 2 and 4 modules of 2 rank by 8 coming after. The 1 rank by 16 modules results fall off a bit behind, although running 2 DIMMs per channel does recover some of that performance. Next up is Call of Duty Modern Warfare 2 using balanced settings. I have to admit I never played this game, but it has a nice built-in benchmark, so why not use it? And it's representative of the shooter category. I chose balanced settings to try to go for more FPS, which I believe is the sort of goal the players of this type of game might prefer over visual quality. Results here are pretty flat. Maybe this title just doesn't respond so much to RAM performance. Third, we have Shadow of the Tomb Raider at higher settings. Again, this is looking fairly flat, apart from the 2 module 1 rank by 16 configuration dropping behind a bit. And finally, we have the classic GTAV. I left it running at game defaults, apart from turning off VSync. Here we do see some scaling. 1 rank by 16 modules do fall behind here. There is a tiny advantage to 4 of 1 rank by 8 or 2 rank by 8 modules. And interestingly, using 4 2 rank by 8 modules seems to give a small performance drop that we don't see in the other titles. Overall, the differences here are very minor. Even in the worst case, it's only about 5% behind the main pack, and any leads for a particular configuration are slim. I would caution this is only under this specific test condition, and it might not necessarily represent others. Putting gaming to one side, I'll move on to compute. These were chosen as a personal interest of mine is finding large prime numbers. Jumping to the right of the screen here is Prime 95. It's quite an often misunderstood piece of software, but it does represent a lot of software in the prime number finding world. And it also has a built-in benchmark. Now, it doesn't give results that are easy to interpret for people who are not interested in the area of prime number finding and hardware. The test condition I'm using here is a relatively large test, and because it's a large test, it doesn't fit on a CPU, and it has to use a lot of RAM, and thus it's impacted by RAM performance. The results speak for themselves. 2 modules of 1 rank by 16 RAM is about 25% behind the others. Using 4 modules does recover a bit of that performance. For the other conditions, it's quite similar to gaming even, with gains in some areas and not so much in others. What about the other 2? I'm using Y-Cruncher, and it's software that can calculate various mathematical values, the most well-known being pi. It is a software used to set world records, and has been for quite some time now, but you can do smaller tests as well, which is quite handy because I don't want to run this for like 6 months continuously. I ran 2 test size here, 25 million and 1 billion digits of pi, which uses about 195 megabytes of RAM and 4.8 gigabytes of RAM respectively. It doesn't seem to matter as results are much like Prime 95. This is an area where you should avoid 1 rank by 16 modules, but other configurations are quite similar. Next up is rendering. There's not much to say here other than this area isn't really affected by RAM performance. The Blender benchmark, it should be noted, has 3 subtests. I'm only showing 2 subtests here. One of them seemed to use 8 gigabytes of RAM by itself, not including whatever the operating system and anything else is taking up. The smaller modules I'm using here are 4 gigabytes each, and you can imagine if I'm only using 2 4 gigabyte modules, that's 8 gigabytes total, and if you're using 8 gigabytes for a test, that is not enough. So performance was negatively impacted, and again, I'm not testing RAM shortage, I'm testing RAM performance when it's not in shortage, so that particular subtest is not shown here. And finally, we move on to synthetics. Here I use Aida 64. I didn't keep up with my license renewals, so my copy is pretty old. It's 2 or 3 years old, I think, at this point. And it does give a warning when I run the latency test that it wasn't written with the CPU I'm using in mind. On the memory read, peak results seem to lie with the 1 rank by 8 modules. I'm a little surprised the 2 rank by 8 doesn't do so well here. Maybe the access pattern they use for the bandwidth testing doesn't match well with the RAM. If we look at writes, the 2 rank by 8 modules do pick up again. Copy is more interesting and it's all over the place. I can only speculate that having more ranks and or bank groups allows the memory to read and write more effectively. And finally, there's latency, where essentially there isn't any difference. Based on this testing, it looks like if you really want to min-max performance, you should probably go for 4 modules of 1 rank by 8. This was generally the best performing amongst all the tests, with 2 of 2 rank by 8 modules coming a close behind. The only thing further to consider about this is, at equal speeds, that would be the case. But the problem is, especially with DDR5 era, running 4 modules is harder to run at high speed than 2 modules. Look at this example on AMD's website, for example. The officially supported speeds fall off a cliff when you put 4 modules in. And even if you use XMP or Expo to run faster memory than standard, the limitations still apply. You will not be hitting as much speed as you would with 2 modules. So as a balance of speed and performance, you might go for 2 modules of 2 rank by 8 instead. Note that the absolute difference in performance between a RAM is quite different from the laptop testing. There could be many reasons for this, since both the CPU and GPU are different as well, and the demands on the RAM could vary from that and other factors as well. I have to admit I'm a little disappointed in how 4 2 rank by 8 modules ran. Maybe the data is getting too spread out in the RAM, causing inefficiencies in trying to get to that data. And finally, we have 1 rank by 16 modules, the ones that sparked it off from the laptop in the first place. Basically, they are that bad. It might be worth considering replacing them if you happen to have them, especially in laptops. It remains a frustration to me to this day that enthusiast module makers don't usually declare what configuration the RAM is. I think this is in part because they often change the configuration of the RAM, but they keep the same marketing name. So when you buy whatever module under the marketing name, what you're getting inside that module could be anything. They can and do change it with very, very little notice. They might change a version number somewhere, or one character in a part number changes somewhere, but there's no way for you to tell what that difference is without buying it, or finding someone else who has bought it. If you buy standard JEDEC RAM, then you're more likely to be able to get this information. So again, the likes of Crucial or Kingston, when you buy their standard RAM, not the XMP enthusiast stuff, quite often they'll have a datasheet or similar. With the small caution again, when I looked at Crucial, they did not give you the choice, but Kingston did. So Kingston, get the nod from me here. Not sponsored. Okay, I'll finish here. I hope this testing was interesting. If there's other configurations or specific software you'd like to see tested in a similar way, let me know and I'll see what I can do. Thanks for watching and see you next time.